In this lesson, we'll look at how we can use the molar mass as a conversion factor to be able to convert from mass to moles or from moles to mass. So the molar mass of an element or a compound gives us a relationship between moles and mass that can be used as a conversion factor to convert between the two. As an example, the molar mass of oxygen atoms are 6.00 grams per mole. So we can use that as a conversion factor if we're trying to find the mass and we have the moles, we'd put the mass on top. Or if we have the mass and we're trying to find the moles, we would put the mass on the bottom and the moles on top. And we can do this because 16.00 grams is the mass of 1 mole. So they're equivalent. 1 mole of oxygen is the same as 16.00 grams of oxygen. So let's look at some examples. So what is the mass of 3.65 moles of arsenic atoms? So first of all, we're going to need the molar mass of arsenic. And we can get that from the periodic table. And it's 74.92 grams per mole. Now, just like we've been doing with previous calculations, we start with the number given in the question, 3.65 moles, and then multiply by the conversion factor from the molar mass. In this case, we're trying to find the mass, so 74.92 grams will go on the top and 1 mole on the bottom, so that moles will cancel. So then you do 3.65 times 74.92, and you get 273.458 grams. Now we need to check our significant figures. The lowest number in the question is 3, the lowest number of significant figures. So 3.65 has 3 significant figures. So our answer has to be given to 3 significant figures, so it's 273 grams. Next example, how many moles of barium hydroxide are contained in a 250 gram sample? So when you see there that you have moles and mass in the question, that means you're going to need the molar mass. So we're going to need to figure out the molar mass of barium hydroxide. And before we can do that, we're going to need the chemical formula for barium hydroxide, which looks like this. Now that we have the chemical formula, we can calculate the molar mass by getting the molar mass of barium from the periodic table, and then we've got 2 times the molar mass of oxygen and 2 times the molar mass of hydrogen. And when we combine all that together, we get a molar mass for barium hydroxide of 171.35 grams per mole. Now that we have our conversion factor, we can go ahead with solving the question. Start with the number given in the question, 250 grams. Since we're trying to find the number of moles, we're going to put 1 mole on the top of our conversion factor and the 171.35 grams on the bottom. So now the grams cancel and we're left with moles, which is what we would like. So you would do 250 divided by 171.35, and that gives you an answer of 1.459 moles. Then we check our significant figures. 250 grams has 2 significant figures, so we express our answer to 2, so we have an answer of 1.5 moles. Next example, determine the mass of 2.4 moles of copper 2 sulfate pentahydrate. Okay, so the formula is given to you there. So the first thing we need to do is calculate the molar mass of copper 2 sulfate pentahydrate. So we've got 1 copper, 1 sulfur, we've got 9 oxygens, right? 4 from copper sulfate plus another 5 from the waters, and then we've got 10 hydrogens. So when we plug in the numbers and add them up, we get 249.72 grams per mole. Now we can find the mass, which is what the question was asking for. So we start with the 2.4 moles given in the question and multiply by the molar mass in the form of a conversion factor. Since we're trying to find mass, the grams will go on the top. 249.72 grams is 1 mole. So the moles will cancel. When you put 2.4 times 249.72 in your calculator, you get 599.328 grams. So now we check the significant figures. So we need 2 significant figures. So to round this to 2 significant figures, you're actually going to have to convert it into scientific notation. Because if you just write 600, then that only has 1 significant figure. So in order to indicate that that second digit is significant, we need to convert into scientific notation. And our last example, how many moles of silver chloride are contained in a 55 milligram sample? So as with the other questions, the first thing is we need the molar mass of silver chloride, which means we need the chemical formula for silver chloride, which is very straightforward, AgCl. So then we're going to calculate the molar mass by adding the molar mass of silver to the molar mass of chlorine. And we get 143.32 grams per mole. Okay, the question gives us a mass in milligrams. So the first thing we'll have to do when we start our calculation is to convert to grams. So we start with the number given in the question. We're going to convert it to grams. And there are 1,000 milligrams in 1 gram. So the milligrams will cancel. Now we're into grams, so we're going to just string another conversion factor on there, this time using the molar mass. We're trying to find moles, so moles are going to go on the top, 143.32 grams on the bottom. So then you do the calculation, 55 divided by 1,000 divided by 143.32, and you get 0.00038376 moles. Now we check our significant figures. We need to have 2 from 55. Remember that 1,000 is a defined value, has infinite significant figures, so we only need the 2 from the 55. We're also going to convert that into scientific notation just because it's a little nicer to look at, not so many zeros. Okay, so there's our final answer to 2 sig figs, 3.8 times 10 to the negative 4 moles. So those are the types of questions you can expect when you need to convert between moles and mass, and hopefully that's helped you understand how to do them.